Hello friends, so today we're going to discuss the top 3 questions from the latest LeetCode bi-weekly contest 35. So let's start. The problems are pretty much good. So the first question is sum of odd length subarrays, in which you are given an array of positive integers and you have to calculate the sum of all possible odd length subarrays. So which means that the odd length subarrays in this array can be of size 1, size 3 and size 5 and so on. Size 1 can be 1, 3, 2, 5, 4, like 5 and 3. Then the odd length, the next length is 3. So 1, 3, 2 is one subarray, 3, like 4, 2, 5 is one subarray and so on. So you have to find out the length of all possible subarrays of size like odd, and you have to output the sum of every subarray, and that's output. Now because the constraints are very small, you can do it in brute force manner also, but you can also find out some patterns. But like I have done it in a brute force manner, but like I have also observed that a pattern can also be seen, because as you can see, let's like paste out this question. So as you can see, the first number occurs in the first subarray of size like odd, then this and like this in the length 5 also. So like every number is occurring, like how many subarrays of odd length are there, because as you can see 4, how many times 4 will occur in this subarray, in this subarray and in the whole subarray. So if you count out how many possible odd subarrays you can make, then you can just multiply every number with that odd number and like you can also get that answer. But you can also make odd subarrays of length like 1 and iterate over the whole subarray like array and then count out the total sum and then output the answer. So like you can do it in both the ways, and like I have done it in the brute force way. So I'll tell you on the code part now. So find out the length of the subarray or the whole array, sorry. Then total is the total summation of all the answers. Then first you have to find out the length or the window size of which is odd. So because it is zero indexing, we will do it with 0, and the length of that subarray, actually it is your seeing that the length is 0, it's actually not 0, it is of length 1, and because it is zero indexing, and then it is of length 1, then 3, that's why we are jumping by 2. Now when we have fixed our window size, then what we'll do, we will fix our starting point. So we will start our starting point from j equal to 0 till the whole array, and we can only make a window whenever our like j plus I is less than n, or if you can make this equal to 1, then you have to subtract 1 from this point also, like whatever like you want. So you can check this condition, we can only make a window if j plus I is less than n, and if this is possible, I have a window size of this I length present. So I have to take out and do the summation of all the elements in this window. So k equal to 0 till the length, and then add up all the elements starting from j till the window size, like j plus window size. So j is the starting point and like k is the window size. So starting point, window size, starting point, window size, and do the summation of all those windows over all the odd lengths it is possible, and then output the total. So that's the simplest explanation for the first problem. Now the second problem is good, in which you are actually given a nums array, and now what you'll do, you are also given some request. Now what you are given in this request is you are given some starting index and an ending index. The ith request which is given to you asks for the sum of the numbers from the like the starting index to the ending index. So as you can see, because this is zero indexing, this is from 1 till this like 4. As you can see, I have taken down, if there is a request from 1 till 3, then you have to add all these numbers. So request 0 means that you have to summation of nums of 1, like indexed 1, index 2, index 3, because yeah, like it is between 1 and 3 inclusive both of these numbers. So this is 2, 3 and 4. Okay, yeah, sorry. So the thing here is actually you are given this like array, or this like array nums array. You can permute this array such that if you encountered all of these n requests, if you do all of these n requests, then the total summation of this n request will be the maximum. Now what you are doing in every request, you are given some like range, you have to do the summation of all the elements in this range. So let's assume that this is the nums array which is given to you. You make it one permutation which is equal to this. Now in this new permutation, if you add the numbers from indexed 1 till index 3, which is like 1, 3, 4, you add them, which is equal to 8. Then do an indexing from 0 till 1. So this is 0 and 1, which is 2 plus 1, which is 3. If you add both of them, 8 plus 3 equal to 11. So this is the maximum total summation of the request which is given to you if you find out the permutation. So the question statement states that you have to find out the maximum total sum over all the requests among all the permutations, like all the possible permutations. You have to find out the maximum total sum you can get, and because the total sum can be very large, you have to model it with 10 to the power 9 plus 7. So that's the whole question. Now, like, you might be thinking like how to approach this question first. Now think over this. Let's assume that I have some array. Just think over some blank places. I have some, like, my first request is increment all, like, do a summation of all the numbers from this range till this range. My second request is do a summation of all the numbers from this range till this range. And my third summation is do a addition of all the numbers in this range. Now as you can see, I can easily find out what is the number which is maximum updated, or the number which is maximally taken in all the requests. As you can see, this number is taken in this request, and this request. So this number is taken in 3 requests, all of the requests. So I can easily find out the number or the request of every number. So this number is taken in the request of 3. This number is like added in 2 requests. This number is added in like only 1 request. This number is added to only 1 request. This is added in 0 request, and so like this is also in 1 request. So I actually get the how many every number is added in the request. Now I should make a permutation such that I should put the greatest number at this position, because I have some permutation like 1, 2, 3, 4, 5. If I put the maximum number on this position, then I know that this number will be taken 3 times. So the total sum it will increase. So, and the total contribution will be 5 into 3, because this number is added 3 times in all the requests. So what you can do, you can just find out this, then sort this in decreasing order, because like after sorting you'll know that okay, after sorting we know that there is one number which is taken 3 times, there is one number which is taken 2 times, one number is taken 1, 1, 1 and 0. Now I should also sort the permutation, which is like 5, 4, 3, 2, 1. Then I will take the maximum number of this and maximum number of this, which means that I should take the maximum number and place it 5 times, because I have placed it at such a position such that it is requested, or it is requested to add 5 times. Then I will take the next maximum number and multiply it with this next maximum frequency, then the next maximum number and the next maximum frequency, and so on. So that's the whole logic for this question. You have to just find out the sorted order of the frequency of every number, and also sorted permutation, multiply both of them correspondingly and find out the total sum. And whenever you are multiplying them, because the total summation can become very large, you just do a modulo. So like answer, whenever you do an answer plus equal to, you just have to, when you multiply this term with this term, just do a modulo of this with them. And that's the logic for this question. Now the main thing is how to calculate this prefix, or like the updation values. And the simplest way to do here is, I'll tell you how. Just make an empty array of size 0, or like all the values are 0. Now let's assume that I have to update all the values in the range from this till this. How I can do an updation? I will mark out this position with 1, and I will mark out, like this is the ending range, this is the ending request, so I will mark out 1 plus indexed of this value with -1. What I'm actually doing here is, I am actually telling that whenever I am moving from left to right, so let's assume that okay, there is only one request, to increment all the values from this position to this position. Okay, so now what we'll do, we can either take all the requests and for every request update all the values. So like there's an updation of values from 1 till 100, so make all the values all the values 1 1 1 1 1, then there's updation from 5 till 100, so again 1 1 1 1. So it is like a very time consuming option. But the next thing can be, you can just mark out the starting index, like there's an updation from 1 index till 500 index. So put a 1 at the first index, and at the 500 plus 1 index put a -1. So how this will help us, let's assume that this is 1 at the starting index. Whenever I move from left to right, I will keep on adding this number. I'll tell you how you're gonna see. So this is 1, so there is no 1 here, so it will be 0 0. Whenever I see a 1, I will put 1 here, and I will keep on, like there is a sum variable which will tell us the total sum till now. So there is no addition number here, so there is the total sum is 0 till now, but now there is 1, so I will make our sum equal to 1. So now because sum equal to 1, I will keep on appending this sum to the next number. So it is like 1 1 1, but now there is a -1, so I will decrease my sum with -1, and now it again become equal to 0, so now it is again 0. So now you can observe that because I am doing a range updation, I am actually updating my starting index with some 1 and my index plus 1 with a -1, such that when I move from left to right, I will update these values in this index with +1. As you can see in this example also, I have put a -1 in the +1, such that if I put a -1 at this point, this will become 0, but I don't want, because I want to updation in this range. So I will put a -1 +1 at this point. And then this is how for every request I will just put 1 -1 for all of these queries, and then in the end I will iterate from left to right and find out the updated, or how many times each value is updated, and then we'll do the same thing which I've told you. So that's the whole logic for the second question. That's also very simple. Okay, yeah. So what we'll do, we will iterate over, we have make a vector a m plus 1 size, m plus 1, because there's an updation in these numbers only, in these numbers. So the total size of this is m, the size of this num set is m, so n plus 1. I've just taken 1 for the extra buffer value. Then what we'll do, we'll iterate over the requests, and for the 0th value, or the like request is of two form, the first value and the left hand side and the right hand side. For the right hand side I will +1, and for the left hand side, what will I do, I will do a left hand side +1 indexed and do a -1 there at that point. And then we'll do iteration from left to right, and for every point we'll do a summation of that point. Actually you can make a variable like this. You can either like make a sum variable and do a sum variable, but you can also do here is, just because at this there is 1, so you are actually carrying forward this value. So what you are carrying forward, like if there is a 1, you just take the previous number, add this number, this is 1, so there is 1 at this point. Now take this number and the previous number, so like it's 1 till now, this number and the previous number 1, take the previous number 1, this number and the previous number, so this number is -1, previous number is 1, so it's 0. So like you can also do this in manner, so like you can do this in any manner, and like we are just doing or updating our array vector. So this is, and then we will sort out the a, which is the which will tell us how many times every number is queried, and actually the permutation a also. So a is this and nums is the permutation, and then total 0. And what we'll do, we will add the multiplication of ai. AI stores the how many times every number is taken, and we do a multiplication of ai into the maximum value in this vector, the permutation which we are given with what I've told you. And we will add this to the total. We have made this to like 2-3 functions which I've also told them in my earlier videos. You can check them out. I've made this mod function, add function, multiplication function to make my work simpler when I'm handling modulus cases, and then like I will just add these values and then answers the total answer. And that's the simplest case for this explanation for this question. Let's move on to the third question now. The third question is very interesting also. It states that you are given an array nums, and then you have to remove, or like you want or you don't want, you have to remove the smallest sub-array. Okay, like you don't want, you also don't want to remove the sub-array. You want to like remove the smallest sub-array such that the sum of the remaining element is divisible by p, which is given to you. And also you are not allowed to remove the whole sub-array, like the answer will become equal to 0, and then obviously 0 is divisible by p. You cannot do that. If you cannot remove, like if there is a case such that you have to remove all the elements, there is not a possibility, then the answer is -1. But if you can remove some chunk, A subarray means a continuous part or continuous elements in this whole array, such that the remaining elements are divisible by p. The summation of the remaining elements are divisible by p. Then you have to find out the length of the smallest subarray, and that's the whole question. Now this question is based on the modulus approaches. So there are a lot of couple of questions I have posted on my channel also to how to solve these problems. So we're gonna first understand, or what we can do here is first do a summation of all the numbers and also do a continuous modulus of this with p, and check that okay, whether in the first case, in the first go only, if I do a summation of all the numbers and it is already divisible by p, then we don't have to remove anything and the answer is 0. But if the modulus is not equal to 0, then we have to remove subarray. Now how much, like what is the subarray we have to remove? Now to find out the subarrays, there are only like 2-3 approaches. Okay, you can use 2 pointers, or like you can use some Kadir algorithm type of thing, or the third is you can use some map to store the last index you want and the current index you want and delete the element between them. And like there can be 1 or 2 approaches also, but like these are the 2-3 most common approaches to find out. If you want to find out some subarray, then these are the 2-3 approaches you have to keep in mind. So now the third approach is used here, because let's assume that you have the total summation of the numbers equal to, let's assume 50, and you want such that it is divisible by a number which is equal to 7. Okay, now if you do a remainder of 50 with 7, it will give you 1. What does this mean? It means that if you do a divisible by 7, it means that okay, if all the summation of all the numbers is not equal to 0, which means that okay, I have to remove some numbers or subarray from this whole array such that the total summation will become equal to like some factor of 7. I hope you understand. Now how you can find out that? The main thing can be the subarray, the sum of the subarray should be such that if I remove that subarray, the summation of all the numbers should be a factor of 7. Like if I want to remove some numbers from 50 such that the summation of the rest of the numbers should be a factor of 7, then only it will become divisible by 7. That's the simplest explanation. But the thing here is how you can find out the subarray. So you have to find out the smallest subarray such that this is actually the complement of 7. What I mean by this is, if I remove a subarray which is which is a modulus of 7. So let's assume I have some subarray whose sum is 49, like a subarray of size 50, like subarray of sum of equal 50. It can be divided into 49 and like 1, which is a this is a total divisible by 7 and this is not divisible by 7. But you can observe here is, if I take a subarray whose sum is 49 from this 50, then we are actually making the subarray such that all the elements are not divisible by 7 after that case also. But if we remove 1 from it, which is actually a complement number that if I put 1 in this number, or if I remove 1 from this number, it will become a modulus of 7. So I have to find out a complement number, not actually a number which is divisible by 7, but a complement number which is divisible by 7, such that the remaining numbers is become divisible by 7. It's a little bit confusing, but what you can do, you can make a map, and map can help you to store the values such that you can store the last complement value. So this is also something little confusing. So if you have a very large number, there's also one very good question on AdCoder, which is like 2019, in which you have to find out a continuous stretch of numbers which are divisible by 2019. So how you can find out? You have to find out all the numbers such that if you're iterating from right to left, if you find out some number, let's assume that you are dividing this continuous stretch of numbers by 2019, and the remainder till now becomes 5. Let's assume, and then you are again moving from right to left, and you again find out that divisible till now become also equal to 5. What does this mean? This is actually a remainder. If you have taken only, like let's assume you have number like 1, 2, 5, 7, 6, 10, like 9 and 7. You are extracting out a number, like you are forming a number 697, then you are forming a number 7697, and your modulus, you are like doing a modulo of this with 2019. Then you can find out that okay, the remainder is 5. Like let's assume. Now if you take out the next bigger number and you find out the remainder of this is 3. Then you take out the next bigger number and the remainder of this is again 5. What does this mean? It means that okay, a number before is giving me a remainder 5 and a number again giving me a number 5. It means that the number in between these two digits is a perfect divisible by 2019. This is like some observation you have to read, or you can read it some on articles. Like if there are two numbers which are giving the same remainder, then the number in between is actually the perfect divisible by 2019. And that's what we're gonna do here also. We will store the index in which we find out that okay, till now the complement number which I have to remove from this is giving me some value, and if that same value happen to like again occur in some later half, then we know that okay, if I take the values from this starting index till this ending index, then if I remove this is the complement of this 7. Okay, so I have to find out the range. So this is a little bit confusing, but the thing here is if I have to find out the range, I have to find out the starting index and the ending index. I can store the starting index in some map value and the ending index we are iterating over it, and then I have to find out the complement. If the same value occur for the starting index and the ending index, then I can take out that subarray. I will make this more clear with the code, and let's move on to the code part now. So what we'll do, we will first, this is k equal to 0. We'll iterate over the whole nums array and first find out that okay, whether the summation of all of this number is divisible by p. If this is divisible by p, then the answer is 0. We don't have to remove out any array. If it is not divisible by p, then like some number is remaining. It means that some remainder is remaining. Then I have to make a map. I have to push back 0 in the map. 0 for the 0th index I have to push back -1 because this is the starting value. I have to push back something. -1 just actually means that there is some index value. Because if I want to find out if I have some index value such that I have to find out some subarray which is starting from 0 and ending at like 5, how many numbers are there in between? 5 minus 0? No, it is actually 6, because 0 is also including and 5 is also including. So if I take -1, so if I do 5 minus -1, it is actually equal to 6. So instead of starting from 0, we'll start from -1. And that's what we do. We'll iterate 0 equal to -1, which means that I'm making my first boundary at 0 and I'm making that index equal to -1. Then we are making two other variables, other and answer equal to n. Then what we'll do, we'll iterate over from left to right, and then we find out the modulus till that point. So other plus nums of I, which what we are doing, we are actually taking all the numbers from the starting till the ith position, adding them and finding out the modulus of that with the p. Then we are finding out the complement of the numbers till now, and then we are checking that okay, whether this complement number is present in the map. I have seen this number, yes. If it is seen in this number, then which means that at what index I have seen that number, from that index till this index, all the numbers in between can be taken out because they are the complement numbers. And if I remove the complement numbers from this whole subarray, then the remaining numbers are definitely divisible by the number p. So how many numbers I have to take out? I, which is the current value, minus the last seen index of that complement number. The complement number is on this position, so I will put map and this complement number position. So I will get the value or the actually subarray size, and I will minimize the subarray size over all the possible subarray size. And then also I will push back, or I will update this other value. Other means that the current modulus value in this map again, because we are iterating from left to right. And in the end we will check that okay, whether the subarray which I have to remove is equal to n. This function is giving that okay, I have to remove a subarray of size n, then only we can get the remaining elements divisible by p. then this is not possible because I cannot take the subarray of size n as a complete, so that the answer is -1. Else we have minimizing over all the subarray sizes, so the answer is answer. So I hope you understand the logic for the third question also. If you still have an doubt, mention down. Thank you for watching this video. I'll see you in the next one. Keep coding. Bye.